All right, we're back. We're on page 189 now. We've just done page 188, which involved us creating a GeoGebra file or a sketch. We stored a lot of things on the calculator. I have all these things stored already, so if you're just jumping in at this video, you probably want to go back and maybe watch the other one, or at the very least store these on your calculator so that you're going to be able to use them, because we're going to need them as we continue on. So first thing on this page is a fourth bird has entered the arena, and he's gonna, or she, is going from 11:2 to 1:12, and it's gonna take 14 minutes to get that done. So this is a different line segment, which is important because you have different strategies for when they're on the same line segment, when they're on opposite different line segments. You just have to like keep track of what's going on. So let's write these equations. So x4, y4. All right, we're starting at 11:2. And then for the x direction, you're going to lose 10, and it takes you 14 minutes. For the y direction, you're going to gain 10 and take 14 minutes. And so this is only valid between 0 and 14. All right, so I want to store this on my calculator. I think what I also want to do is add it to the GeoGebra sketch that we're working on, because that'll allow me to kind of answer, or at least look at, some of the things we're going to do. So first up, going to the calculator. You know, no, first I'm going to add it to the GeoGebra thing, because then we can just like look and see what's happening. So the next question that we want to answer is find the location where birds 3 and 4 intersect, find the times when they're there, right? So let's see. B1 is bird 1's path. B2 is bird 2. B3 is bird 3. They all have the exact same start and end point. So like when they're all graphed, you can't tell. But what's different is they're describing different motion, right? Like each bird takes a different amount of time. 2 of them start in the same place. 1 of them starts in a different place. So that's why we need all different curves for that, even though it's the same like racetrack. They're just running back and forth on like this bird street or something. What I'm gonna do is I'm gonna duplicate this. I'm gonna name it B4 equals, and then I probably shouldn't have duplicated. I should have just typed it in, because I gotta basically erase everything. So we're gonna go 11 minus 10 over, you can like watch it kind of like update as you go, which is sort of interesting. Delete u, 2 plus 10 over 4. If I had one complaint about GeoGebra, it's that editing is like not super easy. Like when you change, basically highlighting is a bit of a disaster, I guess. I don't really know why. I don't know enough about it. But like when you try to highlight, like if I try to highlight this down here, you can see all the like articles that I had to download for grad school today. All about No Child Left Behind, and some bill that replaced it, which I definitely knew about. You see, I'm like still arrowing, but when you're like in a template, it doesn't really like do it, and then all of a sudden you're out. I don't know. That's my, it's a small complaint, but a complaint nonetheless. All right, I want to put the endpoints here. So what I'm going to do is B4 of 0, because that's where you start. And then I'm going to do B4 of, you end when it's 14, right? 14 minutes. So 14. I'm going to put a point on it and then rename it bird 4. So I'm going to do B4 of, V is the name of the slider in this case, I think. Yeah, V is the slider. So I want to do B4 of V. But the slider goes up to 20, and this should really only go up to 14. So we'll do the minimum of V and 14, which means that when the slider goes past 14, this point's just going to sit where it sits. So let me move the slider so we can actually see it. There we go. Okay, I want to rename this one and maybe change the color. So let's see. Settings. So you can change the color in the settings also. I want to make it this color, which I think I had not yet used. So I change the color, and then I click on basic. So you click on the tabs. And I'm going to click up here, say this is bird 4, and I want to show the label. And then I need to close this. So click the X. And okay, so the question on the notes, if you look, is find the location where 3 and 4 intersect. So where do 3 and 4 intersect? I mean, you can see this. It's right there. It's probably 5/8 is my guess. Let's advance the slider a little bit. Okay, so bird 3 gets there maybe at 5.8, maybe not. Bird 4 is going to get there seemingly at 8.4. That looks really good. And then carry through. So we kind of know the answers. Like, I think the answer is going to be 8.4 for bird 4. I think it's going to be 5.8 is my guess. Let's just type it in, 5.8. No. Oh, 6. I probably mean 6. I'm going in the wrong direction. Shit, not 60, 6. I think it's going to be 6. I think bird 3 is going to get there at 6. I don't know. If I knew what bird 3, 5.8. Yes. I think the intersection is 5.8. I think bird 3 is going to get there at 6. I think bird 4 is going to get to 5.8 at whatever I said. Maybe, I don't remember, 8.4, something like that. Okay. So let's go back to the notes, and we're going to set it up, and then I'm going to solve it on the calculator. So we're practicing a lot of skills here. So we got GeoGebra working. That's good, presumably. Okay, so they're on different paths. So we're going to use a system of equations. So the reason you use a system of equations, well, is kind of twofold. You can't assume that they get to the intersection point at the same time unless someone tells you they get to the intersection at the same time. So if they're on different paths, but you know they get to the intersection at the same time, you could just say like x3 equals x4. Because like they have to get there at the same time. So there's got to be a time at which that happens, and y3 equals y4. There's got to be a time at which that happens. And then the time that shows up both has to be the intersection. Like that's got to happen. If you don't know that they're getting there at the same time though, all bets are off. So since all bets are off, we're going to use a system and we're going to use dummy variables. And so the variables, the dummy variables I use are just going to be T3 and T4. T3 is when bird 3 gets there. T4 is when bird 4 gets there. So here's the system. And it kind of looks like a set of parametric equations, so that's annoying. It's like the one place where these concepts overlap, and it's kind of like, there's nothing you can do about it. So we want x3 of T3 to equal x4 of T4. Those are their respective x coordinates will be equal at those times. And then y3 of T3 to equal y4 of T4. Okay, so we got that. And then we'll just use the calculator to solve that. So let's go back. I didn't yet add the equations though for x4, y4. Like right now I have x is 1 through 3, y 1 through 3. Hold on. Ugh. All right. So what are we going to do? We're going to go back here. There's two ways to get here. You can just click, use trackpad and get over, or control and to the left. Hit tab, and then we're going to type this in. So this is 11 minus 10 over 14t. Keep in mind, we think we know the answer. I don't remember what I said it was, but I definitely think I know it. So I can go back to GeoGebra and check in the event that I don't get an answer that I think looks familiar. So I got that. All right, we're gonna solve the system. I actually already typed one in just like to do the previous problem incorrectly, but I'll do it again. Menu 3.7. System of equations, always choose that. I'm gonna say this is T3, T4. But that's annoying on the handheld. So like you might just want to use A and B, or you could just use X and Y. That would be fine. I'm gonna use T3 and T4. So I'm gonna say that X3 of T3 needs to equal, I'm just gonna type them, X4 of T4, Y3 of T3 should equal Y4 of T4. And let's solve for T3 and T4. Okay, so we get 6 and 8.4, which is, I think, what I thought it was going to be. I'm not entirely sure. And then I need to know x3 of T3, y3 of T3. So this, such that this is true. Oh, what? Oh, I got you. I need to put the 3s. 3, 3. Okay, 5, 8. Then you can change it up. You just have to go back in here and change like every 3 to a 4. I mean, you already know. calculator doesn't make mistakes. So like I'm double checking, but I'm double checking something that's just not going to be wrong. So I'm going to go back to the notes and write this in. Basically, it confirms what we got. Like those, I feel those are the answers that we got. I feel like that's true. Let's go. Okay. So we get T3 equals 6. T4 is 42 over 5, or you can write it as a decimal. And then the ordered pair is 5, 8. So let's write this up. We'll say bird 3 gets to intersection point at t equals 6 minutes. Bird 4 gets there there at t equals 42 over 5 minutes. You kind of want to use exact values whenever you can. Intersection point is 5, 8. Okay, so I'm going to stop the video here. The next question is asking, how close do they get to each other? So they're both at the intersection point at some times, but that doesn't mean that's the closest they'll ever be to each other because they're not there at the same time. So what we want to do is try to figure out what's the minimum distance between them. So I'm going to come back in the next video, and I'm probably going to play around a little bit in GeoGebra to see if I can like illustrate that. And then we'll just straight up solve it. So I will be back in the next video to do that. So I will see you there.